Hello guys, today's topic is isotopes. It is the continuation of the topic mass number and atomic number. Key learning points: describe what an isotope is, give example of isotopes, and calculate the relative atomic mass of an element. Have you wondered why many elements on the periodic table have mass written that is not a whole number? Isotopes are the reason for the mass number not being a whole number. For instance, this chlorine, the mass is 35.45. For hydrogen, mass is 1.008. Mass number is nothing but number of neutrons plus number of protons. Neutrons are also whole numbers and protons are also whole numbers. Then why the mass is coming out to be in decimals? So isotopes are the reason for the same. Now what is isotope? Isotope is a different form of an atom of same element, has same number of protons, has different number of neutrons. So defining an isotope, isotopes are the atoms of same element with different number of neutrons. They have the same number of protons. Example: there are three isotopes of hydrogen. All hydrogen atoms contain one proton and one electron, but they can have different number of neutrons. Hydrogen 1 is the most commonly found isotope of hydrogen, having one proton. In the first picture, you can see only one proton, there is no neutron. Hydrogen 2 has one proton, one neutron, one proton and one neutron. Hydrogen 3 has one proton and two neutrons, one proton and two neutrons. The protons and neutrons are found inside the nucleus, whereas the electrons are revolving around the nucleus in energy shells. There's a question time for you. The number of neutrons in an isotope affects the mass number, atomic number, both atomic number and mass number. Pause the video, think, then answer. If you answered mass number, then you are absolutely correct. Again, a question for you. Can you tell the isotopes among the following? Pause the video, think and answer. If you answered 35Cl17 and 37Cl17, then you are correct, because 35 and 37 are the mass numbers, and for an isotope the mass number is different rather than the atomic number, because number of neutrons differ in an isotope, not the number of protons. Standard nuclear notation. Standard nuclear notation shows the chemical symbol, mass number which is denoted by or represented by A, atomic number which is denoted by or represented by Z or Z, whatever you call it. This X is the element symbol, A is the mass number, Z is the atomic number. The mass number can either be written at the top or at the bottom. You'll be seeing many periodic tables which will be having mass number written at the top and sometimes at the bottom. So we have already studied that whichever the number will be more or higher will be the mass number. So from that you can come to know. Isotope notation. Isotope notation is as follows. the element name or the chemical symbol of the element is written first, followed by the mass number of the isotope, not the relative atomic mass. For example, carbon 13 or C13. This represents carbon. This is the atomic number. The smaller one is the atomic number. The higher one is the mass number out of 2. So we will write the name of the element or the chemical symbol with the mass number followed by a hash. Question time for you. What is acceptable shorthand notation for the isotope of chlorine which has atomic number of 17 and mass number of 37? Chlorine 17, chlorine 37, chlorine 54 and chlorine 20. Pause the video, think and answer. If you answered chlorine 37, it is correct because the notation says we have to write either the name of the element or the symbol of the element Cl followed by the mass number which is 37. Again a question for you. Which of the following is correct mass number for iron if iron has 13 neutrons? Pause the video, do the calculation and then answer. If your answer is 56, then you are correct. The formula to be used was mass number. It is equal to number of protons plus number of neutrons. Number of neutrons are 30. Number of protons are 26 because atomic number it is the number of protons. So the answer comes out to be 56. Properties. Isotopes have same chemical properties. This is because the number of electrons determine the chemical properties. Isotopes have the same number of electrons in their atoms. For example, hydrogen 1, hydrogen 2 and hydrogen 3 will all burn explosively with oxygen. All the elements are mixture of isotopes. The mass number on a periodic table is the relative atomic mass of an element compared to carbon 12. There will be one isotope of an element that will be found in abundance than other isotopes. Abundance means in greater or more quantity. For example, isotope chlorine 35, the abundance of it is 75% and chlorine 37 has an abundance of 25%. This means chlorine 35 is of greatest abundance of all the chlorine isotopes. Relative atomic mass. The relative atomic mass of an element in the periodic table is the weighted average of the masses of atoms of the isotopes. Relative atomic mass takes into account the abundance of each of the isotope of the element. The relative atomic mass of chlorine is 35.45 rather than a whole number. This is due to chlorine having two isotopes. Now, calculating the relative atomic mass. The relative atomic mass, also written as AR, can be calculated by using the following equation. This is symbol for summation. Summation of relative mass of each isotope into percentage abundance of each isotope divided by summation of isotope abundance. Mind this, that after addition or summation, this isotope abundance will always be equal to 100 because it will give you the percentage. Calculating the relative atomic mass for copper. The question for us is, copper has two isotopes, copper 63, which accounts for 69% of copper. This 69% is the abundance. Then copper 65, which accounts for 31% of copper. Can you calculate the relative atomic mass of copper to one decimal place? First, we have to multiply 69, that is the abundance, with the mass number, that is 63. Summation, addition of abundance of the second isotope, that is 31, into mass number of the same isotope, 65. The total comes out to be 6362. Then this 6362 has to be divided by the abundance, summation of abundance, that is 69 plus 31, which gives 100. So 63.62 will be our answer, but we want to have it in one decimal place, therefore our answer is 63.6%. Now it's time for you to solve. Calculate the relative atomic mass of gallium to one decimal place. Gallium has two isotopes, gallium 69, which accounts for 60.1% of gallium, and gallium 71, which accounts for 39.9% of gallium. Think, do your calculation, pause the video for some time. If your answer came out to be 69.8, then you are correct. If not, look at the calculation in here and proceed. Uses. Many isotopes are radioactive. They are called radioisotopes, which are used as radioactive tracers in medical procedures to find tumors or diseases. Radioisotopes are also used to preserve food, to sterilize medical equipment, to determine underwater resources. Carbon-14 is the most useful isotope to calculate the age of fossils. Phosphorus-35, it is used to detect ovarian or other cancer cells, as well as we can use it for plant sciences as well. This was all about the lecture. Check out YouTube Shorts or Instagram page for related assessments. Thank you for watching.